There are various metrics which we can use to evaluate the performance of machine learning algorithms, such as the confusion matrix, where we look at the actual versus the predicted. If the actual is positive and the predicted is positive, that will be the true positive. But if the actual is negative but the predicted is positive, that will be the false positive. And if the actual is positive and the predicted is negative, that will be the false negative. And if both the actual and the predicted are negative, that will be the true negative. Based on this, we can compute the accuracy. The accuracy is the summation of TP and Tn over the overall. We can also look at the precision. The precision is looking at this row, which is if the predicted is positive, how many are truly positive. And we can also look at the recall. The recall is looking at this column. That means if the actual is positive, how many are truly predicted to be positive. And the recall is also called the sensitivity. And we can also look at the specificity, which is actually looking at this column, where we look at if the actual is negative, how many is truly negative. And we can also look at the F1 score, which is the geometric mean of the precision and the recall. So in this bite-sized tutorial, we will look at how to evaluate a machine learning for credit card fraud using these performance metrics. Let's go to the Python code. First, we will import the libraries and import the dataset. The dataset is a credit card dataset, which is from the Kaggle dataset. So these are all the features, and the class is at the last column. So they are all together 28 features plus the time and plus the amount. So the class is either 0 or 1. 0 means there's no fraud, and 1 means there's a fraud case. Let's look at the distribution of the classes. As we can see, this is a highly unbalanced data set with a lot of non-fraud case as compared to the fraud cases. If we think that the time and amount are not critical, so we're going to drop them from the feature sets. Next, we'll remove all the missing data. This is followed by creating an SY pair. To speed up the training, we will only select the first 20,000 data. Next, we will do a data scaling using the min-max scaler from Scikit-Learn. So after the scaling, you can see all the data is between 0 and 1. Next, we will do a split for the training and the testing data set. So we are going to use the logistic regression as an illustration. First, we will import the logistic regression model, and then we train the model using the training data set. Next, we will make a prediction using the testing data set, and we will first look at the classification report from the SciKi-Learn matrix. We can see from this table, the precision and the recall is quite low. The precision is 0.6 and the recall is about 0.5 for this logistic regression model. Let's generate the confusion matrix using the scikit-plot library. So this is the true positive. This is the this is the true. This is a true positive, right? There's only 12 cases of true positive, and these are the true negative. There are a lot of cases of non-fraud. And then this is the false positive, and this is the false negative. And then we can compute the accuracy using the SciKi-Learn. The accuracy is quite high, almost close to 1. But if we look at the ROC, AUC score, we get about 0.75. Okay, now we're going to compute all the metrics manually. First, we will need to extract the true positive, true negative, false positive, and false negative from the confusion matrix. Okay, so this is the summary. So first, we're going to compute the accuracy using this formula, and we get about 0.996, which is consistent with the previous data. Next, we're going to compute the recall and sensitivity. And the recall, as you recall, is the ratio of the true positive over true positive plus false negative, and we get 0.5. And the precision is actually the true positive over the true positive but false positive, we get 0.6. And you can see it 0.5 and 0.6, so it's consistent with the classification report from the SciKi-Learn library. You can also compute the specificity, which is not in the classification report, using the formula true negative over true negative plus false positive, and we get about 0.998. So you can also compute the F1 score, which is about 0.5, which is a geometric mean of the precision and recall. You can also use the SciKi-plot library to plot the ROC curve and the precision recall curve. But I noticed the value here, the AUC, doesn't seem to agree with the AUC from the SciKi-Learn. Right, so there is a bit of problem over here. So we can also do similar for other machine learning algorithms, such as K nearest neighbor. So it's much better than the logistic regression. We get a precision of 0.94 and 0.71 with the F1 score of 0.81. And for Gaussian Naive Bayes, we get 0.15 and 0.96, so there's a very bad decision for Gaussian Naive Bayes, and the F1 score is also very low at 0.26. And if we look at support vector machine, we get a pretty good result of 0.94 for precision and 0.71 for recall. And if we look at the decision tree, we get a very good result of 0.95 and 0.88 for precision and recall respectively. And the F1 score is 0.91. And if we look at the random forest, again we get almost same result as the decision tree. So, and lastly, we look at the neural network model from the SciKi-Learn, we get a very modest result. So from all this comparison, we infer that the decision tree and random forest yield the best overall result with the AUC of 0.93. We also compare with the deep learning model using Keras. So we construct a very simple neural network model. We train it with Adam optimizer, and the loss function is binary cross entropy. We did a training of 15 epochs, and this is the loss versus epoch. You can see that it did drop over the epochs, and then we again compute the classification report. We get about 0.78 for precision and recall about 0.88, which is still not as good as the decision tree and random forest. This could be due to the limited data set. And this is the confusion matrix for the deep learning, and the accuracy score and the ROC curve score. So this concludes the video on evaluating the performance metrics for a machine learning model. If you like the video, please feel free to comment, share and subscribe to our channel. Thank you.